So let's jump into the standard approach. So the standard approach has 3 steps. First, you order the backlog, and the backlog can be anything. They can be stories, features, epics, technical work. And if you're doing Scrum or something like Scrum, the product owner owns the backlog and owns the ordering. And so you end up with, after step 1, with your entire release backlog ordered in the way that the product owner wants. And so if everything is done, then the release is good and it can go out into production. And then step number 2 is to size each item using story points. So story points are a very popular technique. They use the Fibonacci sequence to do relative sizing, the Fibonacci sequence 1, 2, 3, 5, 8, 13. You can create those estimates in many different ways. You can use a technique called poker planning. You can use t-shirt sizing, or you can use affinity estimation, which is a way of grouping stories. And I'll go into each one of those in a little bit of detail. And then finally, you do very simple math, which is that you count the number of story points in the entire backlog. You know the velocity, which is how many story points can be completed in a single sprint, and you divide the two, right? So if you have a backlog with 1,000 story points and you have a velocity per sprint of 100 points, then 1,000 divided by 100 is 10, so it takes 10 sprints. So that's the basic approach, a high-level view of it. So let's walk through each of these steps one by one. So ordering the backlog. So a good question to ask is, in your company today, how do you order your backlog? How do you order your portfolio? How do you order your to-do list? So what I see mostly today is that people are using some sort of quantitative financial metric, such as return on investment, to order the backlog. Tanya says that you ask the stakeholders to prioritize, and that's a great way. Often there's some sort of voting mechanism so you can trade off stakeholder desires against each other. What I see companies in Silicon Valley and companies that are increasing their agility doing is using an approach called hypothesis-driven development, in which they actually go out to the paying customer and they validate the value of the items in the backlog. So it's no longer based on an opinion that someone inside of the company has. It's based on customer action, right? So there's a fundamental difference between, a VP inside of the company saying, do this and this and this, and taking each of those and running a little experiment with an actual paying customer and understanding what the customer is going to do with that feature. Are they going to buy it? Are they going to use it? Do they have value? So whenever you can get closer to the customer, right, get outside of the building, that's typically a good idea. And what people find repeatedly is that when they go outside of the building and they actually talk to a customer, instead of talking to people inside of the company, they discover that a lot of the things that they were planning on doing are not actually valued by the customer. So I've seen that in essentially every single case in which I've worked with a company on ordering their backlog. And so when you don't do this, then you get this standard result that you've probably heard many, many times, which is that something like 2/3 of the features are not used or rarely used. So if you simply go to the customer and validate that a feature is going to be used and useful for the customer, you actually immediately triple your speed because you get rid of the 2/3 of the items on your backlog which have no value. Now, it's very difficult and expensive to do. I often find companies that say, we're not closely connected to our customers. Going and talking to our customers is actually very difficult. And so that's an opportunity for improvement. Okay, but if you're just starting out here, just go ahead and use whatever your company's definition of value is. So something like return on investment is a popular definition of value, and you'd order the backlog using that technique. Okay, then the second thing you do is that you size or estimate each item. So you have these items on your backlog, and they can be anything, as I said before. They can be epics, they can be stories, they can be features, they can be technical work. So one way to do that is using poker planning. And so basically you give everyone these cards, 1, 2, 3, 5, 8, 13. The product owner discusses the item, and then everyone shows a card. and you have a little bit of a discussion if there's a disagreement, and you finally converge on a single answer, and that's the size of that item. So the benefit of this approach is that it's extremely well known. It's taught just about everywhere. And this is, for Scrum teams, the most common practice for doing sprint planning. The disadvantage, however, is that when you're doing release planning, you're sizing many, many more items. For example, if you have 10 sprints inside of your release, you're sizing now 10 times as many items. So if it takes you 2 hours to do the standard sprint planning meeting, now it might take 20 hours to do release planning. So that's a lot of time. Another issue is that it's difficult to do in distributed environments. Right? This is very easy to do when everyone is in a room, but it's very difficult to do when you're distributed. But there are tools that will help. I'll show you an example of such a tool. Here's planningpoker.com. And the way planningpoker.com works is that everyone on the team or everyone who's doing sizing signs on to it. And then the product owner types in a short description of the backlog item, and then everyone on their computer screen clicks the card. And so this is a way to do distributed poker planning if that's something that you want to do. A second approach is t-shirt sizing. And so here you shrink it down to something like small, medium, large, extra large, and you estimate using each PBI. The benefit of this is that it's fast. It's faster than poker planning. The disadvantage is that eventually you need to do a calculation. You need to divide the number of backlog items, backlog points, by the velocity. And so the question is, how do you get from a t-shirt sized release backlog to points? So for example, is a small 1 point and a medium 2 points, or is a small 1 point and a medium 3 points? And so doing that calibration is sometimes a little bit difficult. A third technique, which is the technique I typically use for companies that are doing this old school standard size planning, is affinity sizing. So the way affinity sizing works is shown on this picture. So you put the big poker planning cards on a wall. So here you see 8 on the left side, 20, 40, there's probably a 13 in between there. And then for each item on the backlog, one person on the team reads it out loud, right? So a developer, and then asks the product owner questions about that item for no more than 1 minute. Okay, so this is just a single person on the team sizing it after a 1 minute discussion with the product owner. And then they take that sticky, that yellow sticky, and they just put it up on the wall next to the number that they think it's the right size. So if it's a 20, they put it next to 20. If it's an 8, they put it next to an 8. So you do that for all of the items on the backlog. You basically go around the team. So one person does the first product backlog item, the next developer does the next backlog item. And then once you've gone through the entire team, you go again through the entire team, and you keep doing that until you have the entire product backlog sized. And then that's the first phase, and then the second phase is the editing phase. So in the editing phase, everyone looks at all of the sizing that everyone has done, and then they're allowed to make a change. So a developer gets up and says, I think this 8 is actually a 13. And so each person takes a turn doing that. And then you go around the entire team until everyone says pass. So in other words, everyone thinks that the current sizing is the right sizing. And so I've seen teams size 40 PBIs in 1 hour using this approach. And so this approach gets release planning down to a couple hours in almost every case. Teams tend to like this a lot. Product owners tend to like this a lot. And amazingly, it works. Right? I've had lots of people who've been doing poker planning for a long time, and I come in and I talk about affinity sizing, and they'll tell me there's no way that this is going to work with our team. And then they're just amazed when a release backlog is sized after an hour. And so people really like it. It's an extremely efficient way to do sizing. So that's number 2, step number 2. So after step number 2, what you do is you have the sizes for all of the items on the team. So we have a question. For step number 2, does the team go multiple rounds each time a member changes most one? Yes. So let's say Alice, Bill, and Charlie are the 3 members of the team. And Alice changes something. Bill and Charlie don't change anything. So they both pass. Then you go back to Alice because she changed something, and she may want to change something else. Okay? So you keep going around until everyone says pass. So what typically happens here is that everyone places things on the wall. So that's round one. And then in the first editing round, almost everyone changes something. In the second editing round, about half the people change something. In the third editing round, like 1 or 2 people will change something. And then in the fourth editing round, everyone passes. Okay? So one of the interesting things that happens here is that people sort of get that when you're sizing 40 items or 100 items, it's probably not worth spending a whole bunch of time discussing whether something is a 2 or a 3, right? It just doesn't matter. And when you see all of your teammates passing, and you're the only one who's making these edits from 2 to 3, after a while you decide, jeepers, let's go on to the next item, right? So great question. Thank you so much for that question. Okay, and then finally we have step number 3, and in step number 3 we just do this calculation, right? So in step number 2 we had the size of the backlog in points, right? So we just add it up, so let that be n. We have the velocity, that's how many points that we can finish in a sprint, so that's a v. And so the number of sprints is just n divided by v, right? So let's say that the size of the backlog is 200 points and the velocity is 25, and you just divide those two, right? So 200 divided by 25 is 8 sprints, right? So that's the standard approach to planning, and it's what many companies do, particularly companies that are doing Scrum. It's not required by Scrum, but it's definitely the most common practice. So here are some of the advantages and disadvantages of doing this. So one advantage is that it's really fast. The second is that it's super easy to understand. Right? You can do all of the calculations and all of the work on the back of an envelope. You don't need a spreadsheet. You don't need advanced skills. And then there are many, many people in the industry who have done this. So even if you're just starting up your Agile transformation, there are probably people at your company who have done this in some other company. But there are a bunch of problems. Okay? So one is that it's based on just the average case. Right? We're looking at the velocity, which is just a single number of the average. So think about 2 teams, right? One which has a velocity that is an average of 100, but it oscillates between 50 and 150. Whereas another team also has an average of 100, and it oscillates between 90 and 110. So intuitively, the first team has a lot more variance, a lot more schedule risk, because they're oscillating between 50 and 150, whereas the second team is moving between 90 and 110. But this standard approach treats both of those in exactly the same way, because the average velocity is 100. And so when we did the survey at the beginning of this talk, you guys said that risk was really important to understand. And one of the problems with this approach is that it says nothing about schedule risk. It produces a single number. And effectively, it makes it seem as if you're guaranteed to get to that number. And it treats teams that have the same average velocity, but very big differences in the variance of that velocity in exactly the same way. A second big problem is that this approach only works for a single team. As soon as you have multiple teams and you want to know when both of them are going to be able to release because they're combining their work into a single release, it will not work essentially at all, right? It won't work even if they don't have any micro dependencies, right? Even if they're not working together sprint by sprint, and they're only releasing together at the very end, this approach does not work. So one common mistake that people make is that they just take both teams and they treat them independently. And they say, okay, this team is going to release in 10 sprints, this team is going to release in 11 sprints, so together they'll be done in 11 sprints. So that's actually a pretty big mistake, and it will lead to very significant errors in actually understanding when the 2 teams are going to be able to release. And the problem gets worse the more teams there are. So recently I was talking to a company that has a total of 60 teams that release together, and using this approach, would provide an extremely optimistic estimate of when they're going to release. So you would get an estimate using this approach, and say 90% of the time, 99% of the time, you would miss that date.